This is a frame rendered in 2K, and this is a full GPU frame capture. And you can see that the first big part here is just Unity doing its drawing. And then at the end, you can see about 2 milliseconds of drawing from the fast instance renderer, which draws the entire grass and everything green you see here. And this is on a GTX 1080. That's a low to mid-tier GPU. The GTX 1080 is about 20% worse than a PS5 GPU. And there's almost no AAA games that will ever give you such foliage density or foliage detail, even on the most high-end modern GPUs. So let's look at the tricks we're using to achieve this incredible performance. First of all, we have 3 different LODs in total here. You have this really close-up version, which is an actual 3D model with multiple triangles. Then we have the second LOD version, which is just a billboard, which has an alpha cutout texture on it. And then we have a third LOD, which is really just a triangle. It's just a single triangle that is colored identical to the first 2 LODs, but at a large distance, you can really not tell the difference anymore between the 2. Then secondly, we fade between the different LODs. And in the scene view, you can kind of see the fading a little bit, but only really if you focus really hard on it. It's really hard to tell when something is fading from a lower to higher LOD because we use noise and scaling to hide the seams. Then there are 3 main performance culling techniques. The first one is occlusion culling, where we just cull everything that is occluded by the camera. The second one is frustum culling. Here we cull everything that is not inside the camera's frustum on the GPU. And third, we have backface culling of the ground. So if the ground's surface is pointing away from the camera, we can be pretty certain that the small objects on top of that surface are actually not visible and are very likely to be occluded, and so we can cull them. This actually gives additional benefit to the occlusion culling because the occlusion culling needs to be conservative and we can't cull everything except if we are really confident that it's actually occluded. Additionally, this backface culling is a lot cheaper. And we do this in a chunked manner, so we don't cull every instance individually. That would be way too expensive, especially for the occlusion culling. But instead, we cull the ground triangles that the instances are placed on. Then another huge performance benefactor is partial billboarding. This means we rotate the objects towards the camera on a single axis. This vastly increases density of the foliage while not costing that much more. There's also interaction with spherical and box colliders. Then there's also spherical and box cull volumes. And you can also add custom behavior to cull specific regions completely. Like for example, this collision with the red box culling this entire grass here. Then we have skinned mesh renderers working here as well. Here you can also see some fake shadow cards, which are very easy to implement with Fast Instance Renderer. You just take transparent alpha cutout and render it as a transparent directly over the terrain. Then you can also restrict where on a specific mesh things are rendered. For that purpose, there exists a specific tool on the Tools Mesh Painting Triangle Index Painting, with which you can paint onto a mesh and mark what triangles you want instances to be spawned on. We can then save that in the asset and instantly see it in the game. Okay, so this is how you use the asset. We have to do 3 setup steps. First, we will create a manager object and we will add the instance renderer manager mono. Then we will go to our camera, add instance render camera data. We will need to modify the URP asset, which we can find by looking on our camera. We see the URP asset used is the PC renderer asset. So we can go PC underscore renderer. On here, we add instance render hierarchical Z render feature. We're basically all done with the setup. We can go under instance renderer template. And we want to draw this on this object here. So here we have a mesh renderer and we can add our instanced renderer container mono. And here you need to provide a ground source that can either be a mesh, a skinned mesh renderer, or terrain data. We want to draw this on this mesh, so we can right click and copy the mesh and paste it into here. And then we want to draw our template here. on this mesh. Then on here, we need to decide what we actually want to draw on top of this. And we want to draw this grass model here. That is part of the demo. And we see grass drawn onto here. To color this a little bit differently, not pure white. And here we can find enable use of procedural coloring. We will use this, and we scroll down to the colors. And here we can, for now, let's just select black for the bottom color, fade it a little bit in here. Then we want, this is some kind of cave structure, so we want to align it to the surface normal. We did this here by clicking orient objects along normal. Now we can add some wind to it. We click enable wind, and we're already done with our minimal example setup here.